There's a massive problem happening in space right now, and most people have no idea. An interstellar comet called 3I Atlas is racing through our solar system at 153,000 miles per hour. It's only the third confirmed visitor from another star system we've ever detected, and scientists are in a race against time to study it.
Astronomers and space agencies around the world are right now focusing on a comet, the mysterious interstellar object continuing to fascinate researchers.
The problem? In 4 months, this comet will pass dangerously close to Jupiter. The planet's gravity could change its trajectory, making future observations nearly impossible. If we don't gather critical data before March 2026, we'll lose our chance to understand where this thing came from, what it's made of, and what it can teach us about other solar systems. I'm going to show you exactly what needs to happen in the next 4 months, which NASA missions are involved, and why this narrow window is our only shot at unlocking secrets from another star system. Subscribe and let's get into it. NASA's Hubble Space Telescope managed to get a look at it back in August 2025. And what they found raises some serious questions. The nucleus, the solid icy core of this comet, is somewhere between 1,400 feet and 3.5 miles across. That's a pretty big range, which tells you something right there. We don't have great data yet, but size isn't the mystery. It's what this thing is doing. As 3I Atlas got closer to the sun, it started heating up. That's normal for comets. The ice sublimates, goes straight from solid to gas, and that creates the coma and sometimes a tail. But here's the thing, that outgassing, it's causing the comet to accelerate in ways that aren't just from gravity. Scientists call these non-gravitational accelerations. Now, this is where it gets tricky, because we need to know exactly how much this outgassing is affecting its path. If those accelerations are small, below a certain threshold, then we can predict where it's going pretty accurately. But if they're larger, if this thing is venting gas in unpredictable ways, then its future trajectory becomes a lot harder to pin down. And that matters because of what's coming next. But there's something I haven't told you yet. Something that makes the next few months absolutely critical. On March 16th, 2026, 3I Atlas is going to pass within 0.355 astronomical units of Jupiter. Now, an astronomical unit is the distance from Earth to the Sun, about 93 million miles. So 0.355 AU is roughly 33 million miles. That might sound like a lot, but in space terms, that's incredibly close. Here's why this matters. Jupiter has what's called a Hill radius, basically the zone where its gravity dominates. And 3I Atlas is going to pass right through the edge of that zone. Jupiter is massive. It's 318 times more massive than Earth. When something passes that close to Jupiter, the planet's gravity can significantly alter its path. We're talking about a potential course-changing encounter. And here's the problem. We don't know exactly how much Jupiter is going to affect this comet's trajectory because we're still not 100% certain about those non-gravitational accelerations I mentioned. This is our window. Right now, between now and March 2026, scientists need to gather as much data as possible to understand this object before Jupiter potentially changes its course. Because after that encounter, the comet's path could shift, and if we haven't collected the data we need by then, we might lose our chance to understand where this thing came from and where it's really going. And that brings us to the most important question. What exactly are scientists trying to learn, and why does it matter? Let me break this down into what we know, what we need to know, and what we're doing about it. 3I Atlas came from the direction of Sagittarius. That's where the center of our Milky Way galaxy is located. It's been traveling through interstellar space for potentially billions of years. One study suggests it hasn't had a close encounter with another star in at least 10 million years. Some scientists think it could be a 10 billion-year-old time capsule from an earlier age of the universe. Think about that. This object might have formed around a star that existed before our sun was even born. It's now heading outbound toward the constellation Gemini. When it leaves our solar system, it'll be traveling at the same speed it came in, about 58 kilometers per second, or roughly 130,000 miles per hour. First, we need better measurements of its size and composition. The Hubble data gave us a range, but we need precision. Is it mostly ice? Does it have a rocky core? What gases is it releasing? Second, we need to nail down those non-gravitational accelerations. How much is the outgassing affecting its path? This will help us predict its future trajectory more accurately. Third, and this is huge, we need to understand its origin. Where did it come from? What kind of star system ejected it? What can it tell us about planetary formation in other solar systems? Because here's the thing, every solar system is different. The comets in our solar system tell us about our history. But 3I Atlas? It's a messenger from somewhere else entirely, and that's where the race against time comes in. Right now, multiple NASA missions are tracking this comet. Hubble, the James Webb Space Telescope, the Parker Solar Probe. Even Mars orbiters are trying to catch a glimpse. NASA's Punch mission, that's the polarimeter to unify the corona and heliosphere, has been observing it since late September 2025. They've captured images showing the comet alongside Mars, tracking its movement through our solar system. But here's what's really exciting. When 3I Atlas passes Mars on its way out, multiple spacecraft orbiting the red planet might get a close-up view. We're talking about the Mars Reconnaissance Orbiter, MAVEN, and others. And then there's the Jupiter encounter. NASA's Juno spacecraft, which is currently orbiting Jupiter, has a unique opportunity. Between March 9th and March 22nd, 2026, Juno will be close enough to potentially detect radio signals from 3I Atlas using its dipole antenna. Now, we're not talking about alien transmissions here, we're talking about natural radio emissions, specifically signals from hydroxyl radicals, or OH molecules. These are created when water ice sublimates off the comet. In fact, a radio telescope in South Africa called Meerkat already detected these OH signals back in October 2025. It was the first radio detection of 3I Atlas, and it confirmed what we suspected. This is definitely a comet, actively releasing water vapor. So here's what needs to happen before it's too late. Between now and March 2026, scientists need to observe 3I Atlas as much as possible. Every telescope that can see it should be pointed at it. We need spectroscopic data, breaking down its light to see what chemicals it contains. We need to track its brightness changes, which tell us about its rotation and activity level. The optimal observation period, according to recent research, is between March 9th and March 22nd, 2026. That's when Juno will be in the best position, and when the comet will be close enough to Jupiter for detailed study, but before the encounter potentially changes its behavior. After the Jupiter encounter, the comet will continue outbound. It'll pass Earth at its closest approach on December 19th, 2025. But don't worry, it'll still be about 170 million miles away. No danger whatsoever. But as it moves away from the sun, it'll get fainter and harder to observe. By spring 2026, it'll start becoming difficult to track, even with powerful telescopes. And here's what keeps scientists up at night. We might not get another chance like this for decades. Interstellar objects are rare. We've only confirmed 3 in human history. The next one could show up tomorrow, or it could be 50 years from now. We just don't know. So what's really at stake here? It's not just about one comet. It's about understanding that we're not alone in the universe. Not in the sense of alien life, but in the sense that our solar system is part of a much larger cosmic ecosystem. 3I Atlas is proof that objects regularly get ejected from other star systems and wander through the galaxy. It means that right now, there are probably pieces of our solar system drifting through interstellar space, potentially visiting other stars. Every interstellar object we study teaches us something new about how planetary systems form, how they evolve, and how they interact with the galaxy at large. 3I Atlas might tell us about the composition of a star system that formed billions of years ago. It might reveal chemical signatures we've never seen before. It might help us understand the early universe in ways we can't predict. But only if we study it now. Only if we take advantage of this narrow window before Jupiter's gravity potentially alters its course, before it fades from view, before it's gone forever. So what can you do? First, understand that this is happening right now. This isn't some distant future event. Scientists are actively observing this object as we speak. Second, if you have access to a telescope, even a small one, 3I Atlas is currently visible in the pre-dawn sky. It'll remain observable until spring 2026. Amateur astronomers have already contributed valuable data on other comets, and every observation helps. Third, stay informed. NASA is releasing updates as new data comes in. The story of 3I Atlas is still being written. And finally, appreciate what this represents. We're living in a time when we can detect and study visitors from other star systems. That's extraordinary. 100 years ago, we didn't even know other galaxies existed. Now we're tracking objects from other solar systems as they pass through our cosmic neighborhood. The clock is ticking. March 2026 is coming fast. And after that Jupiter encounter, 3I Atlas will continue its journey into the depths of space, carrying secrets from another star system that we may never fully unlock. Unless we act now. The question isn't whether we'll see another interstellar visitor. We will, eventually. The question is, will we be ready? Will we have learned enough from 3I Atlas to know what to look for next time? That's what makes the next few months so critical. That's why these matters. And that's why scientists around the world are racing against time to study this cosmic messenger before it's too late. If this video opened your eyes to what's happening in our solar system right now, hit that subscribe button so you don't miss future updates on 3I Atlas. Drop a comment below and let me know. Do you think we'll discover more interstellar objects in the next few years, or will they remain incredibly rare? And if you know someone who's fascinated by space and cosmic mysteries, share this video with them. They'll thank you for it.